Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic trouble code DTC P16E8, specifically related to the PGM-FI programmed fuel injection system in the Honda CRV models from 2017 to 2022. The P16E8 code indicates a communication error within the LIN, local interconnect network system associated with the shutter grille, which is a crucial component in improving vehicle aerodynamics and efficiency. The shutter grille operates by controlling airflow to the radiator and engine compartment, thereby maintaining optimal engine temperatures while enhancing fuel efficiency as it opens and closes according to the engine's cooling needs. In this context, the issue may stem from various factors, including communication interruptions between the shutter grille system and the powertrain control module, PCM, which serves as the brain of the engine management system and home to numerous DTC codes that could shed light on the underlying problem. Understanding the components involved and their functions is critical for effective troubleshooting. The P16E8 DTC indicates a malfunction in the LIN communication network, primarily affecting the shutter grille's operation. The shutter grille is an integral component that regulates airflow, contributing to vehicle efficiency and engine cooling. Located at the front of the vehicle, it consists of upper and lower sections that open or close based on engine temperature requirements. The powertrain control module, PCM, communicates with the shutter grille through this LIN, sending signals to operate it correctly. If the PCM fails to receive proper feedback from the shutter grille, or if the signals are interrupted, the P16E8 code may be triggered. Ensuring that both the shutter grille and PCM are functioning and communicating effectively is vital for maintaining the vehicle's performance and efficiency. Several factors could contribute to the appearance of the P16E8 code. Primarily, there may be wiring issues in the LIN network, which could include corrosion or damage to the wiring harness connecting the shutter grille to the PCM. Faulty internal components of the shutter grille itself, such as activation motors or sensors, might also result in communication errors. Furthermore, a defective PCM may send or interpret signals incorrectly, leading to operational malfunctions. Communication interruptions caused by poor connections or loose terminals could exacerbate the issue. Diagnosing these potential causes requires thorough inspections and testing of the wiring, connectors, and component functionality. Vehicle owners may notice several symptoms when DTC P16E8 is present. Commonly reported signs include engine performance issues, such as reduced power while accelerating, which may stem from improper airflow management due to shutter grille failure. Additionally, increased fuel consumption could arise as the vehicle's efficiency diminishes when the grille fails to operate correctly. Drivers might also hear unusual noises emanating from the front of the vehicle if the shutter grille experiences mechanical issues. Finally, the check engine light on the dashboard will likely illuminate, alerting the driver to potential problems that should be addressed through diagnostic testing. The initial troubleshooting step for diagnosing DTC P16E8 requires first turning the vehicle to the on mode, preparing the onboard systems for diagnosis. Once the vehicle's systems are active, utilize the HDS, Honda Diagnostic system, to clear any existing DTCs logged in the memory, allowing a fresh assessment. Subsequently, turn the vehicle to the off, lock mode. This is crucial as it resets the vehicle systems and ensures that any new data can be accurately collected. After waiting for a duration of approximately 10 seconds, re-engage the vehicle to the on mode to facilitate a new diagnostic check for pending or confirmed DTCs using the HDS. This step determines whether the P16E8 code persists or if intermittent issues exist. In this second step of troubleshooting, the focus shifts to checking for both pending and confirmed DTCs using the HDS. It's essential to verify if any other codes, specifically DTC P16E8, appear, as this indicates a related issue with the PGM-FI-ACG alternating current generator LIN communication system. If DTC P16E8 is confirmed, this suggests a potential cascading problem that requires more intensive investigation and subsequent corrective measures, leading you to step 5 of the process. On the other hand, if DTC P16E8 is not indicated, the procedure continues to step 3 to check for further potential faults within the vehicle system. Continuing with the diagnostic process, this step involves checking for any additional pending or confirmed DTCs, specifically looking for DTC P16E8 associated with the PGM-FI battery sensor. If this code is present, it suggests that another critical component is experiencing a communication problem. Consequently, efforts should be directed to step 10 for resolving this issue. In scenarios where DTC P16E8 is not detected, it's necessary to differentiate between vehicles equipped with and without the auto-idle stop system. This distinction helps in identifying the next steps in troubleshooting and directing the technician to the corresponding next step based on the vehicle's specific configuration. At step 4 of troubleshooting, the HDS is employed again to check for additional pending or confirmed DTCs, specifically targeting DTC P16E8, which indicates a communication error related to the PCM and DC-DC converter. If this code appears, it necessitates immediate action, leading to step 15 for further investigation concerning the PCM's communication pathways. Should DTC P16E8 not be indicated, the process progresses to step 20, ensuring a thorough examination of the vehicle's electrical systems, wires, and communication lines to identify any underlying issues contributing to the P16E8 DTC. In step 5, the procedure requires turning the vehicle to the off-lock mode, which helps ensure that electrical systems are inactive for safety while inspecting the components. Next, the technician needs to disconnect the shutter grille's upper and lower 4P connector, allowing for resistance measurements between designated test points. This involves using a multimeter to assess resistance between terminal female number 3 of the shutter grille connector and body ground, evaluating whether the resistance meets or exceeds 1 megaohm is critical to determine the integrity of the circuit. If the resistance is found to be adequate, the troubleshooting moves to step 7. However, if it falls below threshold, proceed to step 6 to investigate for shorted wires within the circuit. Step 6 focuses on checking for shorted wires within the circuit linked to the LIN system. This requires the technician to jump the SCS, short circuit sensor line, using the HDS, which sets the stage for continuity testing. A wait of more than 1 minute is necessary after performing the jump to allow the system to stabilize. During this phase, the technician will continue checking for continuity between the shutter grille 4P connector terminal and body ground, while selectively disconnecting corresponding connectors, including those for the PCM, alternator, battery sensor, and DC-DC converter. The key objective here is to determine if the continuity is lost when any of these connectors are disengaged. If continuity ceases at the disconnection of a specific connector, it indicates that the LIN wire is in good condition, and investigation should shift to replace the component that caused the disconnection. If continuity persists, this suggests a short within the LIN circuit that requires repair. In this step, the process requires reconnection of the shutter grille's upper 4P connector to re-establish baseline functionality. Following this, The alternator's 1P connector should be disconnected to assess the resistance readings between respective terminals. Measuring resistance between terminal female number 1 of the alternator connector and body ground provides insight into circuit integrity. Just like previous resistance checks, determining whether the resistance is above 1 megaohm plays a pivotal role in discerning if the system is functioning correctly. If the value recorded is indeed acceptable, the procedure can advance to Step 8. However, if it fails the resistance test, replacing the upper shutter grille will be necessitated. Step 8 involves a similar approach to the previous check, focusing on the lower shutter grille. After reconnecting the shutter grille's lower 4P connector, the technician must measure the resistance between terminal female number 1 of the alternator connector and body ground. This measurement assesses if the circuit continues to maintain proper integrity. The established threshold of 1 megaohm again serves as a benchmark. If resistance meets this value, it indicates no issues with the lower shutter grille's operational wiring. In the event that resistance falls below this threshold, replacement of the lower shutter grille is required, as it suggests internal faults preventing proper communication and operation. Step 9 specifically addresses open wire checks within the LIN circuit. To begin, the SCS line is jumped once again with the HDS to stabilize conditions for accurate readings. Following this, the shutter grille's upper and lower 4P connector, along with the PCM's connector A, must be disconnected, allowing for precise resistance measurement between the respective test points. The key focus is evaluating the resistance between the terminal female number 3 of the shutter grille connector and PCM connector A number 10. For the circuit to be considered in optimal condition, resistance must equal 1.0 ohm or lower. If it meets this criterion, LIN communication is deemed functional, and the technician should refer to authorized service information or consider a known good PCM substitution. If it exceeds this limit, repair measures should address the open wire connection along the circuit. At Step 10, similar procedures as before are implemented, commencing with turning the vehicle to the off/lock mode to ensure safety prior to disconnections. Once the systems are powered down, the shutter grille's upper and lower connectors need to be completely disconnected for testing. The next task involves measuring resistance between specific test points at the shutter grille's connector terminal and body ground, following the same guidelines established in previous steps. Ensuring that resistance measures 1 MOA or more confirms the integrity of the circuit. If this value is validated, it leads to Step 12 in the troubleshooting progression, while a failure in this threshold prompts further investigation in Step 11, assessing for possible shorted wires in the LIN communication network. This step is essential in asserting the condition of connections within the LIN system. Initially, the SCS line is jumped with the HDS to establish a stable testing environment. The goal is to check for continuity between the shutter grille 4P connector terminal and body ground while disconnecting the relevant connectors incrementally, including the PCM, the alternator, and the battery sensor. Measuring continuity is pivotal to ascertain if any disconnection initiates a break in the circuit. If continuity ceases upon disconnecting a particular connector, it indicates that the investigated LIN wire remains intact. Thus, that specific component should be replaced. If continuity is maintained, this test confirms the presence of a short between the components within the wiring network that necessitates further repairs. Step 12 re-engages the upper shutter grille 4P connector, ensuring the circuit is restored through further evaluation. Following this, it is necessary to disconnect the 12-volt battery sensor's 2P connector to facilitate a resistance measurement. Just as previous tests, the measurement should be taken between terminal number 2 of the battery sensor and body ground. Validating that resistance matches or exceeds 1 megaohm will indicate that the wiring is operating correctly, allowing the diagnostics to progress to step 13 if all is satisfactory. If resistance falls below this threshold, replacing the upper shutter grille may become necessary, as it may likely indicate failure within the component's wiring. In step 13, the focus shifts back to the lower shutter grille after reconnecting its 4P connector. Resistance measurements must again be taken. However, this time, between terminal number 2 of the battery sensor and body ground. Ensuring a reading of 1 megaohm or greater is imperative. The integrity it indicates suggests all wiring is functioning correctly. If the resistance does not meet this standard, it strongly indicates a failure within the lower shutter grille's wiring or mechanism, necessitating its replacement to restore proper functionality and communication within the vehicle's LIN system. The focus at step 14 is on the integrity of the LIN communication circuit. The HDS is again utilized to jump the SCS line, setting the conditions for accurate continuity measurements. Disconnect the shutter grille's upper and lower connectors, along with the PCM connector A, to allow for a complete assessment of the circuit. Referring back to previously established criteria, measuring resistance between terminal number 3 of the shutter grille connector and PCM connector A number 10 is essential. If the resistance is measured at 1.0 ohms or less, this indicates that the LIN communication wire is functioning properly. Alternatively, if this standard is not achieved, it points to a need for repairs in the wiring linking the shutter grille and PCM. Reiterating previous diagnosis methods, step 15 necessitates turning the vehicle to the off lock mode. Disconnecting the shutter grille's upper and lower connectors allows for one final assessment of the circuit integrity. As before, a resistance measurement is crucial here, mapping the connection between terminal female number 3 of the shutter grille and body ground to check for resistance. Recording a resistance measurement of 1 megaohm or more reinforces the viability of the wire circuit. If the threshold is met, this leads to step 17. However, emissions below this threshold propel the technician towards step 16 to further investigate any short circuits present in the LIN communication network. Returning to the continuity check, step 16 requires jumping the SCS line with the HDS. This setup allows the technician to accurately isolate issues in the LIN system. Subsequently, continuity tests are performed between the shutter grille 4P connector terminal and the vehicle's body ground, while sequentially disconnecting connectors such as the PCM, battery sensor, and alternator harness. The critical aim here is to observe whether continuity is maintained after every disconnection. If a specific connector's disengagement results in a loss of continuity, it pinpoints the fault source for swift replacement of the malfunctioning part. If continuity remains intact across all disconnections, the technician must investigate for shorts within the LIN circuit leading to faults. Moving to step 17, the technician will reconnect the shutter grille's upper 4P connector to allow tighter inspection of connections. This is followed by disconnecting the DC-DC converter connector A, 3P, to evaluate the circuit's integrity in relation to the shutter grille. Resistance measurements should occur between terminal number 1 of the DC-DC connector and body ground. Establishing that the resistance is 1 megaohm or greater affirms that the wiring properly functions within specification. If resistance levels fall below this threshold, the next necessary action is replacing the upper shutter grille, as it indicates that the component may have internal failures impacting its operation and communication. At step 18, attention is redirected to the lower shutter grille after a reconnection of its 4P connector. The focus now involves disconnecting the DC-DC converter connector A for further resistance evaluation. Assessing the resistance between terminal number 1 of the converter and body ground is critical to ascertain that expectations for circuit integrity remain stable. Once again, a measurement of 1 megaohm or more is essential to validate proper communication pathways. If measurements do not conform, the recommended course of action is to replace the lower shutter grille component, reinforcing effective operation in the overall vehicle system. Step 19 proceeds similarly, targeting open wire checks. The SCS line is jumped with the HDS as part of the preliminary setup for continuity testing. Necessary disconnections include both shutter grille 4P connectors and PCM connector A, enabling a thorough examination of the circuit across the relevant terminals. Measuring resistance between terminal female number 3 of the shutter grille connector and PCM connector A number 10 is critical to affirming the circuit's integrity. If resistance rings in at 1.0 ohm or less, it verifies that LIN communication is intact, signaling the technician to consult the service literature for any other related issues. Conversely, values exceeding this range indicate open wiring that necessitates immediate repairs along the specified LIN circuit. This penultimate troubleshooting step involves ensuring the fuses related to the shutter grille system are intact. Begin by turning the vehicle to the off-lock mode, allowing for safe inspection of the fuse panels. The specific fuses to check include number G31 and number A23 for the upper shutter grille, alongside fuse number A22 for the lower variant. A blown fuse may indicate underlying shorts in the system. If any fuses appear compromised, detailed inspection of the associated wires, particularly the VMP, variable motor power wire, connects the fusible linkages to the shutter grille components. Ensuring fuses are correctly intact is vital before advancing to the final diagnostic steps. At this stage, the technician will disconnect the shutter grille's 4P connector to facilitate the measurement of voltage levels necessary for confirming the operation of the system. Using a multimeter, voltage should be measured between the designated test points at the connector, namely, female terminals number 1 and number 4. It is imperative that battery voltage is observed. Otherwise, it would suggest significant underlying issues in the electrical system. If battery voltage is confirmed at the test points, investigation will lead it to step 23, ensuring further scrutiny of the circuit. If voltage is not present, it indicates a failure likely between the grid wire connections, which require rectification to resume full operational capability. The focus of step 22 is to delve deeper into the GND and VMP wiring to assess operational conditions following the fuse checks. Continuing after voltage testing, the technician will measure voltage between specified test points, with the shutter grille's connectors still disconnected. Verifying whether battery voltage appears at these points will dictate the need for either wiring repairs or component replacement based on the readings. If voltage is indeed absent, this confirms an open circuit flaw, necessitating fixes in the grounds and VMP lines, ensuring robust connectivity and functionality throughout all components in the LIN system axis. In the final step, focus returns to validating the integrity of the LIN circuit. Again, the SCS line is jumped with the HDS to prepare for continuity checks. Disconnecting the PCM connector A leads to a measurement of resistance occurring between terminal female number 3 of the shutter grille connector and PCM connector A number 10. This is imperative to ascertain representation of proper LIN communication. Obtaining a measurement of 1.0 ohm or less affirms that wiring connections and LIN integrity are intact. leading to the resolution of the DTC issue. If resistance exceeds the threshold, it requires repairs, addressing the open circuit flaws within the LIN wire connecting the PCM and shutter grille. The final verification process is essential in confirming that the implemented repairs have effectively resolved the P16E8 issue. Start by clearing any residual DTCs from the system using the HDS, resetting the onboard diagnostic monitoring strategy. Following the clearance, a test drive should be conducted to evaluate overall vehicle performance and ensure no symptoms related to the shutter grille communication errors reappear during operation. Prior to concluding, a recheck for any DTCs via the HDS will help confirm whether the repairs are successful and whether the vehicle has returned to its optimal operational state. A successful clearance indicates that communication with the PCM has been restored and the P16E8 code will no longer be active. To prevent recurrence of issues associated with DTC P16E8, implementing a proactive maintenance strategy is recommended. Regular inspections of the connectors, particularly those associated with the shutter grille and PCM, can help identify early signs of wear or corrosion that may introduce faults into the communication system. Additionally, routine checks on all wiring within the LIN network for signs of damage or deterioration can mitigate risk before they manifest as communication errors. It is also advisable to keep the vehicle software updated, as upgrades may contain critical fixes, improving system efficiency and functionality. Lastly, monitoring overall vehicle performance can provide insight into any emerging issues before they escalate into larger problems requiring significant repairs. In summary, DTC P16E8 is indicative of communication issues between the PGM-FI system and the shutter grille, which is vital for regulating airflow and maintaining engine efficiency. A thorough understanding of the components involved, alongside a strategic troubleshooting approach, is critical for identifying and resolving the fault. The process elaborated reflects the necessity for systematic diagnostics, addressing potential wiring faults, grounding issues, and component malfunctions. Adopting preventive maintenance practices post-repair can enhance vehicle reliability and minimize the risk of future communication errors, ensuring the vehicle operates within optimal performance parameters. Awareness of these strategies offers insights not only into resolving the current DTC, but also maintaining overall system health. Please like and subscribe to the channel. See you next time.